Hi, today I want to talk about the Spring 4 updates of our project, the machine learning project. So for Spring 3, we was working on the model to distinguish the in-hill from the exhale. And for this sprint, we're going to improve the accuracy because the accuracy was pretty low. Also, we need to visualize our model to use some visualization techniques because we want to make our model understandable for anyone, not just the professional ML scientists. The first process to improve our model is the data pre-processing. There are too many labels now, like inhale, exhale, silence, noise. To make it more accurate, first we want to remove the noise so that the data could be cleaner. After we remove the noise, we try the neural network. There are two neural networks currently. The first one is CNN, which just doesn't work, and we turn out to use FFNN. Finally, we reached accuracy at 0.45, which is about like a little bit worse than guessing. You can see the graph here, like there's a lot of silence. However, there are more inhale than exhale, but our model predicts less inhale than exhale. Like this model cannot really reflect the actual events. The next step, so we want to improve our model, and our next try is to remove the silence. Like if we don't have the silence, there's only inhale and exhale, well, which would be much easier to do. After remove the silence, we visualize the data like this. There are the inhale and exhale are kind of like it's roughly the same, and when we explore the data, we found out that for each data points there are 300 features, which is crazy. To make it easier to visualize the model, we reduce the dimension and down to 3 features. So you can see there are X, Y, Z axis, and here is our data points. We can put them in a space. Then we use unsupervised learning. Like there are two techniques. We first tried k-means. For k-means, you can see the data points are divided into two groups. Like one is kind of inhale and the other is exhale. For those groups, we test the accuracy, and finally we reached something a little bit better than guessing. Like 0, if the score is 0, which is completely guessing, and our model is a little bit better than that. Then we also tried dbScan, which is another method. The data points are here, and as you can see, they are divided into two groups, the red one and the orange one. And finally, we reached accuracy, well, still a little bit better than guessing. Then we tried other method, which is supervised learning. There are two kind of methods we tried: the XGBoost and the random forest. To try those models, we just combine the models with a lot of different chunk of data. Well, at the beginning, we have about 2 hour audio file, and we divided the file into smaller pieces. Each piece is like 50 milliseconds, 100 milliseconds, like that, and so that we can have different kind of data. We use those data to train the model and test accuracy, and finally, we find out that okay, the best chunk of data is the 200 for random forests. And finally, we reached accuracy about 0.56, well, which is still a little bit better than guessing. Here is the visualization of the result. So finally, is the conclusion part. Just as we just presented, our results is just a little bit better than guessing. However, when we are labeling the models, is even it's for humans, it's very difficult to distinguish the inhale from exhale. Like for example, the first time you listen it, okay, you think it's inhale, and after maybe 5 minutes, you come back and you listen again, you will think, okay, this is exhale. Well, so for human, it's just guessing. Our model are use the data labeled by human, so we don't think we can expect higher accuracy. Moreover, we don't have efficient data sets. Our data set is only about 2 hours before remove the noise and the silence. If we remove it, maybe just about 30 minutes or 1 hour, maybe. So we don't have enough data for training. That's one challenge. And finally, our model doesn't count the noise and silence, which results that our model is like it doesn't work for real world situation because there will be a lot of noise and silence in the real world. That's one shortage of our model. That's all. Thank you.